Okay, so we're about to start chapter 11, which, as you can see, is on infinite sequences and series. Okay, so the first thing I want you to note is that in this chapter, it's not like we're being introduced to the idea of a sequence or a series for the first time. Okay, we were introduced to sequences and series in algebra. And so in the algebra playlist, we go into full detail on what is a sequence, what exactly is a sequence, what exactly is a series. And so if you're following along in the calculus playlist, then after this video, I've put some videos from the algebra playlist so you can rewatch the full description on what exactly is a sequence and series, the notation, the meaning, the rules, etc. Because yes, in these opening sections, the calculus textbook is going to give some brief statements on what a sequence is and what a series is, but it's not an official full introduction. So it'll be helpful for you to rewatch those algebra videos. Okay, so if we're not being introduced to sequences and series in this chapter, then what are we doing? What are we studying? Well, as the chapter title shows, what we're studying in calculus is infinite sequences and series, right? This is calculus. That's what we study in calculus. What happens as functions approach infinity? Or what happens when a function gets infinitesimally close to a value? What does the function do? Well, we're going to do the same thing with sequences and series. What happens as the number of terms of a sequence approaches infinity? What happens as the number of terms of a series approaches infinity? Okay, now, if you're taking a Calculus 2 course, you've gotten through integrals, you're probably worn out and just ready to finish the class. But I would urge you to try and still focus as you go through this chapter. Because yes, sequences and series are concepts that you don't encounter as frequently as integrals or derivatives, but they still do come up in science and engineering and research. So, I've read research papers and technical books on like, for example, digital image correlation, where they use a power series to represent a function. That they use the first 3 or 4 terms of a power series to represent a function. And they do this because the terms of a power series are easier to differentiate. Sometimes you can't differentiate a function as it is, but if you represent it as a power series with like 3 or 4 terms, then you can differentiate it. Or you can do other things with it that you couldn't otherwise do. Okay, when you study partial differential equations, okay, so you've got 2 categories of differential equations, ODEs and PDEs. You have ordinary differential equations, which are just based on a single variable, like from single variable calculus, and then you have partial differential equations, which are concerned with more than one variable. So that corresponds to multivariable calculus or calculus 3. Well, when solving partial differential equations, for a lot of cases, the final answer is going to be given as a summation or a series. Okay, now you might be saying, well, how could I possibly use a series in practice for like a real life situation? Well, what you can think about is that the final answer is a sum of infinite terms, right? The final answer is a full series. But if you were actually trying to apply that, like if you were putting it into writing it into a software or something, you would just use the final answer. You would use the first 3 terms of the series, 4 or 5, whatever, however accurate you want it to be. If you use the first 10 terms, that's like more than enough accuracy, right? So when it comes to like actually applied mathematics and engineering, it's a different world. We're not as concerned with exact answers as like a mathematician would be. We get a final answer as a series. Well, then just take the first 5 terms or whatever you want. A computer could do the first 20 terms if you wanted to, no problem. And that's like more than enough accuracy for the answer. Okay, but still though, you're still dealing with these series, power series, Taylor series, etc. Okay, so this is an important chapter that you want to focus on. Okay, now the last thing I want to talk about before we get into this is, so I'm saying infinite sequences and series. So what exactly does that mean? Well, as I mentioned, you're thinking about the idea of what happens when the number of terms of the sequence go to infinity, or the number of terms of the series go to infinity. But so more specifically, so as I talk about in the algebra videos, if you can have a sequence, this is a sequence. You can write a sequence this way. Like it's a sub n. Okay, and so for most sequences that we deal with, we're able to write a formula, an expression that it's a function of n. Sometimes you can't do this, but most of the cases we deal with, you can do this. And what that means is, what that's saying is that you can, if you want to know what's the third term of the sequence, then you plug in 3 into that formula. If you want to know the 10th term, you plug in 10. So it's a formula for the sequence. Now, with any sequence, any sequence is going to have a corresponding statement of the domain of the sequence. So like the domain of the n. So, you'll be given a sequence, like a sequence formula, and then there'll be a statement saying that n is greater than or equal to 1 or greater than or equal to 0. However, it's not a requirement that sequences have to start at 1 or 0. Technically, a domain of a sequence could go from negative infinity to infinity. The only strict requirement for any sequence across the board is that the domain of any sequence has to be an integer. You can't input, for a sequence, you can't input 1.5, okay? But the vast majority, most of the time, a sequence is going to be defined to start at like 1 or 0. I mean, in special cases, it could start at, you can start it wherever you want. You can start it at 10. You can start it at negative 15. But most of the time, the domain is going to, the sequence is going to start somewhere. It's not just going to go to negative infinity. And then even further than that, most of the time, it's going to start at 1 or 0. Okay? And so what you can think about is that the idea of an infinite sequence is we're analyzing what happens as n goes to infinity. You can think about what happens as n goes to negative infinity if the sequence is, the domain is negative infinity to infinity. But most cases, we're thinking about what happens when n goes to infinity. That's what we're studying about a sequence, okay? Now, a series, what we learned in the algebra videos was, so you can think about a series as, well, okay, a series is you're summing the terms of a sequence. Okay, that's what a series is. You're summing the terms of a sequence. And the way you can look at this is, one way you can write a series is you put a summation symbol, and then you take an a sub n, and you just put you replace the n with an I. And the I is for, because it's for the summation. You go from I is equal to 1 to n. So you see what this means. You're summing the terms of the sequence. I would be 1, wherever I would be wherever the sequence starts. So if the sequence starts at 0, you put 0 here. If it starts at minus 10, you put minus 10. And then n would be the nth term. So if the sequence had 50 terms in it, or whatever the n goes up to, that would be n, right? If it goes to 50, you'd go from the first term to the 50th term. You'd sum the terms of the sequence. Or, maybe you have a sequence that has 500 terms, but you want to sum the first 50 terms of the sequence. So you still just do 1 to 50. Or you want to sum the 20th to the 50th term or something. It's however you want to write it. Okay, but when you're summing the terms of a sequence, that's what's called a series. You have a series. Now, okay, so what is an infinite series then? Well, an infinite series, as you can imagine, is you're just doing this. You're just taking the limit as n goes to infinity of the series of this. And again, same idea. If the domain of the sequence is negative infinity to infinity, then, I mean, that's more confusing. But in general, we'll talk about that later. But in general, we're going to be dealing with sequences that start somewhere, most of the time at 1 or 0, and then we're thinking about what happens to the sum of the sequence as n goes to infinity. This is what we're thinking about. That's what we're going to be studying in this chapter. Okay, now the last thing I want to talk about before we get into this is you might get confused with the terminology associated with sequences and series. And so the calculus textbook kind of uses these terms one way, And the algebra textbook uses these terms another way, and it gets confusing. The calculus textbook, they'll use the term series when they're talking about any infinite sum. So if it's an infinite sum, it's a series. If it's not an infinite sum, it's not a series. And maybe they just do that because all sums, most of the sums that we're concerned with in this textbook or in this chapter are infinite series. So they just use the term, they just drop the term infinite. I'm not sure, but the least confusing way to look at these terms is, so you have finite sequences and infinite sequences, and you have finite series and infinite series. Okay, a finite sequence it's a sequence that contains a finite number of terms. 50, you can specify what it is, 50, 100, 1,000 terms. Same idea with a sequence. You're summing a finite number of terms. All right, and then obviously if you have a sequence with an infinite number of terms, then you call that an infinite sequence. If you have a series where you're summing in an infinite number of terms, that's called an infinite series. Now, what you can do though is that you can refer to any sequence, whether it's infinite or finite, or any series, whether it's infinite or finite, as just a sequence or as just a series, right? So you say, look, you tell someone, look, I want you to take a look at this series. You give them the series, they look at it, they say, okay, so this is an infinite series, and or this is a finite series, right? That's the idea. Okay, so let's get started with the opening section.